just let me know if you have any questions on those first two. You just had to do that whole completing the square thing. So you get your x squared bracket and your y squared bracket. Now guys, in this case, because there was just a y squared, you didn't have to put that into a bracket, right? If it's just a y squared, you're going to leave it as y squared. And that means that your y value of your center is 0. So that was something that was a bit different about 2E. Any questions on those first two? Okay, let's move down so that you can see J as well. In J, there was an extra step. You have to first divide every term by that 3. So the 3x squared and the 3y squared. So now you have to divide every single term by 3, not only the x squared and the y squared, right? Every single term. That will give you that second line. And then what I did next was I just put my x terms together, y terms together, and I put the 2 on the other side. It did become -2, right? But that's okay because we're going to add stuff to it. Right, so then make it constant. And then if you're looking at this one, 2 over 1 is just 1. Sorry, 2 over 2. Sorry, we're adding b over 2 squared, right? So b over 2, the b value here is 2. So 2 divided by 2 is 1. So that's where that 1 squared comes from. My b value here is 3. All right, so that means that you're adding 3 over 2 squared. Okay, which is a fraction, but that's okay. You can do that. 3 over 2 squared. Then on the other side, you have your -2. You must then add your 1 squared, which is just 1. And then 3 over 2 squared. Then you put those 3 terms together in one bracket. Remember, you take the x from the x squared, the 1 from the 1 squared, and that first sign. For the y, you take the y from the y squared, then the 3 over 2 from the 3 over 2 squared, and again that first sign. So they were both pluses. And here, when you add all of this together, you get 5 over 4. Which is also a fraction, but that's okay. It's a working fraction. So from there, the center is -1, -3 over 2. And your radius is going to be the square root of this. So guys, the square root of 5 over 4, when you type it into the calculator, this is what comes up. Because the square root of a fraction, remember, is the square root of the numerator over the square root of it. Now 5 doesn't have a square root, that's why it's written like that. But the square root is always 2. Okay, let me just check what that is in decimal form. Maybe we going to write it like that, which is just fine. 1,12. Okay, what do you find for this version? Any questions on that? Now, guys, it's pretty much guaranteed to get a question like that. Where they're giving you a circle equation in this form, in standard form, and you have to put it into the other forms. So I think we've done 6 now. We've done 6.0, 6.5, and we've done a couple in class, so you've lots of examples of that. But if you're able to do this, guys, it's basically, I mean, if it was a complicated one like this, that would be 1 mark. That would probably be 2 marks for adding the 1 squared and the 3 over 2 squared to both sides. 1 mark maybe for putting, maybe 2. That's probably 1 mark for putting those 2 brackets together, then a mark for the center and a mark for the radius. Okay. Out of it, in a test out of 50, that's 14%. Yeah, it's not, it can be, I'll tell you guys, this is a bit faster to the bunch of times. It follows the same method every single time. It just follows that one. Okay, number 3 was that question that we discussed briefly in class. It was given slightly differently, but like I said, they're not always just going to give you the center and ask you to write the equation. In this case, they gave us the end point of the diameter, right? Remember they said that A and B are end points of the diameter of this circle that we're trying to find the equation of. Yes, sorry. Right, so if we have a diameter and A and B are the endpoints, then we know that the center of the circle is going to be the midpoint of the diameter. Alright, so I'm just, it's obviously not to scale or anything, but just to show you, the circle would then go all around through A and B. Alright, and the center of the circle will be the midpoint of the diameter, so that's what I wrote there. And guys, like I said in class, when we're trying to find the equation, we need to think, what do I need to write the equation of the circle? I need the center, and I need to be able to find a value for r squared, the radius squared. So the center is the midpoint of the diameter, so 5 minus 3 over 2 will be the x value, and 3 plus 6 over 2 will be the y value. So that is how I got those coordinates. And once you have the coordinates of your sets, you can put those in the equation, right? If it's a positive one, it's going to be x minus 1. Positive 3 over 2 is going to be y minus 3 over 2. Okay? Just for this, guys, you'll get 3 more for you. Okay, they usually give 2 more for finding the center, 1 for x and 1 for y, and then 4 for writing it like that, and you already have 3 more. Okay, then I did write down 2 methods that you could have used. The quickest method would be to actually take either point A or B. I decided to work with A just because it has positive values, and sub it into that equation, right? Because if you put your x value in for x and the y value in for y, you're only left with r squared, which is the only thing that we still need to find in order to write this equation. So that would be the quickest way of doing that. Sub those 2 values in, type it into the calculator, and we'll let you finish the other 4. And then that's the equation. The 2 brackets equal to the radius squared. Or you could have found this length and halved it. That would be the radius, but then you have to still square it. Or you could have found this length between your center, because you just find the center and point B, for example, and square it. Or that length there, that's going to be the radius. But that would have been a bit longer. It's easier, quicker to do something. Any questions on this one? All right, number 10, 10A, I said you guys would be able to do 10A. 10B was very difficult. I don't know if anyone managed to get an answer to 10B, but this is 10A. They gave you 2 circle equations and asked you to find the center and the radius of each. So there we have 2 more examples of that kind of question, right? So you have to complete the square. So here, you add in the other 2 squares. Now guys, here I already took away that minus. Right, you could have still done negative 10 over 2 and then in another line left after minus. I just did that straight away. So B would be negative 10. When you divide that by 2, you get negative 5. But then we know that negative 5 squared and 5 squared will give you the same answer. So that's why you didn't leave out that minus there. Same thing here. 1 squared. You can add those same values to the other side. So the center here was 5, 1, and the radius was the square root of 45. But remember, if they say you must leave your answers in simplified form, then you have to write a bracket. Okay, so please, if you wrote the square root of 45, that's fine. Just make it equal 3 root 5. Okay, you can do that just by typing it into the calculator. And then for the other one, the method was the same. So you can take a look there. The innovations on 10A. 10B was a difficult one. They said, yeah. For 10B, they were saying, I think show that the 2 circles touch internally or something like that. Let me just check 10.3. Yeah, so 10A was saying determine the center and radius of each of the two circles, and B, show that the circles touch each other internally. Now that basically means that one of the circles is on the inside of the other one, but they also touch, right, at one point. So I decided I just labeled that first center A and the second one B. Just do that if you're going to write down the answer now, because otherwise you're writing center of one circle and center of the other circle. It just makes more sense to actually give each center a name. So as I was thinking, okay, if the one circle has to lie inside the other circle, let's look at the radii here, right? Because remember the radius is the length from the center to any point on the circumference. So for the first circle, the one at the center A, do we see that this radius is bigger than the other one? 3 root 5 is obviously bigger than 1 root 5, right? Does that make sense? So if we're looking at that, that means that the smaller circle, if it has a smaller radius, it's going to be a smaller circle. Does that make sense? You have a radius of 3 root 5 and a radius of 1 root 5. So this bottom circle is the smaller circle. We can call it circle B, all right, because it has a center of B. So that one would be smaller than this circle A. So what we actually have to prove is that circle B lies on the inside of circle A. All right, because circle B is smaller than circle A. That makes sense? Okay, the bigger one can't lie inside the smaller one. Can't fit inside, right? So what I did was I decided to calculate the length between these two centers. I'll show you on the picture now as well why that works. So I found the length, the distance between these two centers. All right, so just write that down, find the distance between the two centers. And I actually got that distance was 2 root 5. I'm just using the distance formula for that, right? X value of 1 minus x value of the other squared plus y value of 1 minus y value of the other one squared. Then I got 2 root 5. So guys, isn't 2 root 5 the difference between the big radius and the small radius? Right? And that actually is what gives us the answer. It's a bit difficult to visualize, which is why I'll show you a picture now. Maybe it will make more sense then. But that's what I was trying to explain in the next one. The radius of the biggest circle, I said, okay, let's use a capital R to represent that, is 3 root 5. We calculated that in A. The radius of the smaller circle was 1 root 5. So if I take the big circle's radius and I minus the smaller one, it does actually give us the exact distance between the two centers. So that does mean that the two circles touch each other internally. I'll show you now on the diagram, and maybe it will make a bit more sense because it's quite abstract the way that it's written. Quickly gonna see if I can just plot these two circles. Just finish copying that down and then I'll show you the picture. And guys, in the test exam, like I said before, they will give you the pictures. So then maybe if you actually have the diagrams given, it will be easier to figure out how to prove this. A little bit more time for everyone to finish. Does it make sense? So what I've said, that the circle with the center B is smaller than the one with center A because the radius is smaller. All right, so if they want us to prove that they touch internally, that means that the smaller one has to lie inside the bigger one. All right, they also could have asked us to prove that they touch each other externally. In that case, the sum of the two radii would have to be the distance between the centers. All right, that's all. Okay, let me just show you the picture. This is from the teacher's guide where we did actually draw it. Okay, so this is that center A, that center B. What did we say? We saw that the radius of center A, the circle of center A was 3 root 5, right? That was the radius, 3 root 5. Then we got that that was root 5, and the distance between the two was 2 root 5. Right? So because the distance between the two centers is exactly the difference between the two radii, that means that they touch each other, right? Because the sum of those two lengths is 3 root 5, which is that radius. Now guys, if they had given us a different circle, right? If B was maybe over there, and the circle looked like this. Oh gosh, sorry, that's not showing to tell. You get the idea. What would the length between the two centers have to be? 3 root 5 plus 1 root 5, right? 4 root 5. Then that would prove that the smaller circle is outside the bigger one, right? Because that distance between the two radii would be bigger than the radius of this circle. But because it's exactly, it would be exactly the same radius. Okay, we'll come back to that. I'll see if I can find some more examples like that because they often do put a question like that in the final exam. So this is just the first one. We often have some time after it just needs to work on it. Okay, I'm going to teach you the last section quickly of circles, and then for the rest of this week we can circle back and we can just practice all the different types together. Okay. So I have started making the notes along. You guys can just copy that down. The equation of a tangent to a circle. This is the last type of line that we're going to have to work with. But for example, 3 types of lines, right? Find the equation of the median, altitude, perpendicular bisector. This is now the last type. So long. Okay, so guys, whenever you see the word tangent, I want you to think straight line. Okay, tangent will always be a straight line. It can never be anything else, but they're not going to call it like a tangent line. Or, you know, they're not going to tell you that it's a straight line. You need to know that. Tangent is always a straight line. And we know that a straight line equation always has to be written in this form. Y equals mx plus c. So if they're asking us to find the equation of a tangent, then this is what we're needing to find. Okay, just like with those 3 other lines that I listed earlier, median, altitude, perpendicular bisector, all right? We also have to find equations of those lines. Same thing here. Now what a tangent actually is it's a line that touches, now I wrote curves. Yeah, this year we're just going to work with circles, all right? But next year, we're going to work with tangents to other types of curves. So maybe a parabola is also an example of a curve, right? A parabola is not a straight line. But we can actually have a tangent to a parabola as well. Okay, we'll do that second. So it's a straight line that touches the curve in the fifth circle at only one point. That's the important thing. Let's underline the word only there. Only one point, and that is the point of contact. So guys, when we are trying to find this equation, remember what did we do? Somehow we found the gradient, and then we always have to sub in a point when we find the equation on a straight line. Guys, remember? Find the gradient using whatever we got now, but then in order to sub in a point, we're always going to have to sub in the point of contact. Okay, that is the important point when we find an equation on a tangent. So like I wrote here, y equals mx plus c, we're going to have to find that. Now, this is something that's very important, guys. This is also something that is always true. A tangent is always perpendicular to the radius of a circle, wherever that tangent is. If we're just thinking of a circle, right? The circle goes all around the center. You can have a tangent at any point on that circle, guys. Anywhere around that circle, you can have a tangent. At that point where the tangent is, you're going to have a radius as well. Let me show you the picture in the notes. Sorry, I thought I had a textbook here, but I can't find it now. All right, there we go. So there we have a circle. They just have two examples here. This is from the matric textbook. That is an example of a tangent. Okay, so it's a straight line that touches the circle at only one point. Guys, if the line goes through the circle, we call it a secant. Okay, you don't have to know that really, they don't ever use that. But a tangent only touches the circle at one point. Now, this is what they're showing here in this block. The angle between the tangent and the diameter or the radius, all right? We know that the diameter is just an extension of the radius. So like I wrote there, the tangent is always perpendicular to the radius. Okay, what is the radius? The radius is the point going from the center to, in this case, the point of contact. So how can I find the gradient of the radius? What's the formula for the gradient of the radius again? Change in y over change in x. And I have 2 points, don't I? The center of the circle and the point of contact. All right, so we're going to write that down, but that's what you're going to do first, guys. We are going to find the gradient of the radius, which is always from the center of the circle to the point of contact. Then you're going to use that product of gradients equal to -1 to find the gradient of the tangent. Okay, there's another picture here. Here they have a diameter, all right, but we can still find the gradient of this line. There we have the center, there we have the point of contact. The tangent is always perpendicular to the radius at that point. Okay, so that is what I tried to explain there. Tangent perpendicular to radius. Maybe let's add at point of contact. Right, so therefore, you're going to use this. Remember, when two lines are perpendicular, then the gradient, the product of the gradient, is equal to -1. Okay, we used that a lot before. We're going to use that again. To find the gradient of the radius. Gradient of the radius. Use center and point of contact. Remember, to find the gradient, you always need 2 points. Okay, so those are going to be the 2 points that will use for this types of question. The center of the circle and then the point of contact, which they will either tell us or we'll have to maybe calculate it in some other way, which is when we do questions. So we're going to say that the gradient of the radius is change in y over change in x. Sorry about that. We're going to do some examples. Sorry, I just need to pull it up here again. So they also have a sketch here, but again, guys, this textbook is a bit irritating because they don't give you the sketches and then they say draw a sketch, which you'll never have to do in a test or exam. All right, I promise we will always give you the sketches. So I'm just going to write down this sentence. You guys can actually copy it from the board quickly. This is example 1. You can just write examples and then number 1. This is the first one. Then we'll look at the picture and then we're going to calculate it. Okay, so we're going to find the equation of the tangent to this circle, x squared plus y squared equals 25, at the point T, which is 3, 4. Okay, so just write examples and then number that one, number 1. What is there on the school today? Okay, guys, so they've drawn the picture here, right? If we're looking at x squared plus y squared equals 25, what is the center of that circle? If you're just looking at that equation, x squared plus y squared, there are no brackets, hey? So that means it has to be 0, 0, right? Do you remember the first circle that we did? Equation of a circle with center, the origin, that was the heading, I think. All right, so if there are no brackets with your x and your y, then that means that your center is 0, 0. We'll write that down now. What is the length of the radius, by the way? If it's 25 in the equation, it's going to be 5. Okay, we don't actually need that in this case, but that is what's happening. And they're saying at the point T, which is 3, 4. So they've drawn it here. All right, we see that we have a circle with a center at the origin. And then the point of contact is 3, 4. And they've drawn the tangent so that it is just touching the circle at that one point. They want us to find this equation. Okay, not the equation of the circle. They've given us that equation. Not the length of the radius. We can, but they're not asking for that. They want the equation of this line. Now, guys, what we're going to do, we're going to first find the gradient of the radius, which we can do because we have 2 points on the radius. You see that we don't have 2 points on the tangent. How many points do I have on the tangent, actually? Just 1. That's not enough for me to calculate the gradient, right? If I want to use change in y over change in x, I need 2 points. So I'm going to find this gradient using those 2 points, the center and the point of contact. Then I'm going to do that product equal to -1 thing to find the gradient of the radius, because I know it's of the tangent, sorry, because I know that these two are always perpendicular. And then, guys, I need 1 point lying on the tangent to sub into the equation. Like I said before, we only have 1 point on the tangent, the point of contact. So that is the only one that we can sub in. Okay, let's do that. So the equation of the tangent to the circle, blah, 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 at the point 3, 4. Okay, now the first thing that I always write down is the coordinates of the center. We saw it on the picture, all right, but if they've just given us the equation, then it's a good idea to write it down. So the center is 0, 0. And the point of contact is T, which is 3, 4. And this point of contact is the most important point, guys, because this one actually lies on the line. It lies on the tangent. So this is the one that we're going to sub in. Lies on tangent, therefore sub n. So we're not going to do that yet. Before we can sub n, we first need to find the gradient, but it's important that we do that. A lot of people sub in the same type of circle when they're trying to find the tangent, but you can't do that. You have to sub in the point of contact. Okay, so first we're going to find the gradient of the radius. You can write m of r when you're doing this yourself, but for the first example, let's just write it off properly. Gradient of the radius, change in y over change in x. Okay, so with these 2 points, the 2 points that we have, the center and the point of contact. So change in y, I'm going to take this y value 0 minus that y value 4 over the x value, which is also 0 minus the x value, which is 3. Alright, that's going to give you negative 4 over negative 3. The 2 minuses are going to cancel out, so your answer is 4 over 3. That's your first mark, guys. Remember, this is not the gradient of the tangent, this is the gradient of the radius. The tangent is perpendicular to the radius. So now we're going to say gradient of tangent times gradient of r is equal to -1. You don't have to write this in brackets on the side when you're doing it. Let's just write it now because it's the first example. We can do this because the tangent is perpendicular to the radius. Okay, so the gradient of, I'm just going to use a t now, times the gradient of the radius that we calculated was 4 over 3, so we can now put that in, equal to -1. So the gradient of the tangent, now you're going to say -1 divided by 4 over 3, right? On the side of tangent, right? When I move it across, I have to divide by it. So that's going to give you -3 over 4. You can just type that into the calculator, right? -1 divided by 4 over 3 is -3 over 4. This is now the gradient that we're going to work with. This is the gradient of the tangent. And if you remember that picture that we saw, the tangent does have a negative gradient, right? It was sloping down. So it makes sense that we're getting a negative gradient. Let me show you that picture again quickly. Right, the gradient of the radius is positive. You see, because it's going up. We did get +4 over 3 for that one. The gradient of the tangent, it does have a negative gradient, this line, right? Because it's literally, it's like going down, it's sloping down. Okay, so our picture does fit our answer so far. All right, so now we're going to say we know that we have y minus y1 equals -3 over 4 times x minus x1. Remember that's the formula that we use when we find the extension of a line. In order to use that formula, we now need to sub in a point on the line. And I've said it before, I'm going to say it again. The only point on this line is the point of contact. That's the only point we can sub in. 3, 4. We're going to say y minus, remember y1 is the y value of this point that we're subbing in. 4 is equal to -3 over 4 times x minus x1 is the x value of the point that we're subbing in. Just going to multiply these brackets out. We have -3 over 4 x plus, we're doing -3 over 4 times -3, that's +9 over 4. But we're not done yet. I still need to move this -4 over to the other side and add 4. I'm going to have -3 over 4x. Let's see, I should be able to do that in my home plus 425 over 4. Okay, that is the equation of the tangent. Just in terms of mark allocation, again, you'll get a mark for that gradient. You'll get a mark for showing your substitution here, and then a mark for your final one. And guys, just like with the previous work, these are the exact steps that you're going to follow every single time they ask you to find the gradient of the tangent. Okay, first step, gradient of the radius. Second step, use this formula to find the gradient of the tangent. Third step, sum in the point of contact. Fourth step, make y the subject. Move everything else together. I just want to see quickly what the next example is about, because maybe we can determine the equation. Okay, so this is similar, guys, but in this case, you see that the equation of the circle is not given in center radius equation form, right? It's given in standard form. So what would I have to do here to get the coordinates of the center? What do we call that process again? Completing the square. Hey, you would have to do that whole thing that you guys practiced over the weekend. You'd have to complete the square to get your x squared bracket, your y squared bracket. That will give you the center. But after that, everything's exactly the same. All right? Gradient of radius, gradient of tangent, sub in point of contact, and then get your equation. Again, they've given you the point of contact, right? For now, I think in grade 11, they always will. In grade 12, they might. We'll get to that eventually. But in grade 12, they might expect you to find the point of contact yourself. Okay, but in grade 11, it's quite straightforward. You just follow those same steps every time. We'll get to that one later. I just want you guys to practice. Sorry, let me just actually zoom out here. I just want you guys to practice a few of these kind of basic ones. Points of intersection, we'll still get to that. All right, so from number 3, let's see what exercise is this. Exercise 10.4, page 262. Exercise 10.4, page 262. I want you to do 3A to C. All right, that's down now. Exercise 10.4, page, what did I say now? 262. Exercise 10.4, page 1, 3A to C. Sorry, I'm just seeing that we want to all have a comparison. So maybe let's go into 3A and B. One yesterday, and then 5B. Guys, please have that example open in front of you, the one that we just did. You're literally copying those exact steps. Okay, that's the nice thing about this section is they quite a few types of questions that will be the same every single time we need to do them. So if you just practice enough, then you could get very good marks for this. Is that big enough? Because I zoom in a little bit more. Oh, sorry, it's frozen. Oh, I'm sure it's not. Just I might have to move my lines there. Can I wipe that stuff off the board there? I just want to try. So 20 minutes left. I'm sure you can get most of that done in that time. And guys, we are going to still be working for the rest of this week. I know that we have shorter days, but please don't stay home